Today we're looking at Geometry Section 10.5. We'll be finding the area of regular polygons using trigonometry. Our first example is asking us to find the area of a regular pentagon with 8 centimeter sides. So I've drawn a picture of a regular pentagon in. I've labeled the 8 centimeter side, and I also have labeled a few other points. The first is the center C, and I've drawn in the radius C to X, and also C to Z as a radius. They form a triangle there that looks like a little piece of pie. And then inside that I've drawn the apothem from the center down to point Y. Since XC and ZC are both radius of the pentagon, then they each are the same length, which makes that an isosceles triangle. So when I drop that apothem down perpendicular to the side, it bisects the angle at C, and it also bisects the side XZ. So each piece XY and YZ will be the same measurement, and they will be half of the side. So down here on my triangle that's drawn below, I'm going to write a 4 in. So I've just taken the triangle on the left side, XCY, and I've drawn it down below a little bit bigger so we can look at it as we go. The next thing we need to know is what the measure of that angle XCZ is. That's the measure that's made with the angle that's made with the center C. It's not the small angle in the triangle here. It's the larger angle in the triangle above. So with any regular polygon, we can find the central angle is what that's called. We can find the measure of that by taking 360, which would be all the way around a circle, 360 degrees, and we divide it by the number of sides. So this would be divided by 5. And we've done this in the other section, but just as a reminder. So when I divide 360 by 5, I get 72 degrees. So that's the central angle. When I look at just half of that triangle, the one where I have the apothem as the height, that will be half of 72 degrees. So 72 degrees divided by 2 is 36 degrees. So that small angle at the top, XCY, will have that measure 36. Now, thinking back to the trigonometric functions that we had, sine, cosine, and tangent, tangent was the one that did not use the hypotenuse. And since we don't have the hypotenuse labeled, which would be CX, I'm going to use tangent because I've got an opposite side, which is XY, and an adjacent side that I'm looking for, which is labeled A, but it's CY. So what I can do is set this up as tangent of 36 degrees is equal to the opposite side, which is 4, has a measurement of 4, over the adjacent side, which we're calling A, as the apothem. All right, so just as a reminder, this is opposite over adjacent. Now, if I want to solve for A, I would multiply, since A is in the denominator, I'd multiply both sides by A. It would get rid of the one on the right side, and I would have A times the tangent of 36 equals 4. I would need to then divide both sides by the tangent of 36 so that I could have the A by itself. Now, if you put this into your calculator, you should get about 5.5. So thinking back to the formula for the area of a pentagon or any other regular polygon, in the other section that we looked at, we learned that it was equal to 1/2 the apothem times the perimeter. So now we know the apothem is 5.5. We don't know the perimeter, but we do know the side length, which is 8 centimeters. So for the perimeter, we would just need to multiply 5 times 8. That would give us that the perimeter is 40 centimeters. Okay, so now I have enough information to be able to plug it in. I have 1/2 times the apothem, 5.5, times the perimeter, which is 40. Each of those are in centimeters, even though I didn't write the units down. So my answer will be in centimeters squared. I would just put this in on my calculator, and I would get about 110 centimeters squared. And that would be the answer that I was looking for. Now, quick check 1 is asking you to find the area of a regular octagon with a perimeter of 80 inches. And then they want you to give the area to the nearest tenth. So pause the video and try this on your own before you restart it to check your answer. Now on this octagon, I don't want to have to draw the whole figure in. It's really hard to draw an octagon that looks regular. So I'm just going to draw a triangle that was formed with one of the central angles there. And I'm going to draw an apothem in as well, just like we did on the other one. So here I don't know the side length, but I do know the perimeter is 80. So if I divide that 80 by the number of sides, which is 8, that would mean each side is 10 inches. Okay, so that would be the whole piece of this triangle at the bottom. Now, I also need to know the angle. So we really want to have a right triangle to deal with like we did last time. So if this is my apothem, I need to know what this angle is at the top. And I know that if the whole side length is 10, then this small triangle will have a side length of, or a bottom leg of 5, because that apothem bisected the bottom side there. So again, what I'm going to do first is I'm going to find the measure of the larger angle, which would be 360. It's always 360 for these problems, divided by the number of sides. That's going to, this time, give me 45 degrees. So that's the large angle. The angle that I have drawn below is half of that 45-degree angle, because the apothem bisects the angle and the side across it that it intersects. So that angle will be 45 divided by 2, which is 22.5 degrees. Now I'm going to solve this just like I did the other one. I have an angle 22.5 degrees. I'm going to use tangent because I'm not given the hypotenuse. I am given a leg, and I'm looking for another leg. So if it's including just the legs, it's going to be tangent. The opposite side would be the one labeled 5, and the adjacent side would be the one labeled A. So now I would solve this. I would have A times tangent of 22.5 equals 5. And then I would divide both sides by tangent of 22.5 to solve for A. Okay, when I solve for that, I will get about 12.071. Well, that's taken a little further than I need it to go. Since I'm going to round to the nearest tenth, when I'm doing my calculations inside the problem, it's good to take your decimal places one past what you're going to round to. So I'm going to keep up to the nearest hundredth on this one, which would make it 12.07. Okay, so that's my apothem. I'm already given the perimeter. So I have everything I need. I have area equals 1/2 times the apothem times the perimeter. So that's going to be 1/2 times 12.07 times 80. when I multiply all of this out, I'm going to get about 482.8 square inches, or inches squared. Now, another thing in this section is we're going to talk about finding the area of a triangle in a different way than we've learned before. So I've drawn a picture of a triangle in and labeled as much as I can. The capital letters are the angles. The lowercase letters are the sides across from those angles. I've also drawn in the height. So here it says, suppose you want to find the area of the triangle, but you know only the measure of angle A, which we would be here, and the lengths B and C. If I want to use the formula 1/2 base times height, we need to find the measure of the height. So what I'm going to do is I'm going to figure out what that would be. So I would have, if I know B and I know C, I could say, let's see, I also want to find H. So if I'm thinking of this small right triangle, with my angle A here, and my height, and C is the hypotenuse, and if I know that measure, I can do this. So what I will do is I want to figure out what the height is. I know that the base in this case is B, as it's labeled in the triangle. So I just need to know what the height is. So using this triangle, the red triangle I've drawn, I could use a trig function. So I might, if I'm going to do H over C, H is the opposite side, C is the hypotenuse. I would be using sine. That's the definition of the sine ratio. So sine A would equal H over C. And I want to figure out how to put H into my formula up here, so I need to rearrange it so that the H is by itself. So I'm just going to need to multiply C times the sine of A. And that should equal my H. Now if I'm thinking of using my formula, area equals 1/2 base times height. I actually think I want to write that out, because some of these letters we're using more than once. It looks a little confusing. So 1/2 times the base length, whatever that is, times the height. So in this case, the height, we're going to use our C times sine A, but we're using the length B from here as our base length. So 1/2 B times the height, which we're calling C times sine of A. So this gives us another formula for finding area. If we know that I have an angle and two sides that are on either side of it, so it's kind of that side angle side scenario. We know two sides and their included angle. Then I can use this formula that was given to find the area. Okay, but it has to be that your two sides are B and C, and the angle A is the angle that's in between those two sides. So in this case, we had our B here and C here, and my angle A was the angle in between those. It was the vertex where those came together. All right, so we're gonna use this on an example. Okay, so example 3 has the surveyed lengths of two adjacent sides of a triangular plot of land are 412 feet and 386 feet, and the angle between the sides is 71 degrees. So I have some kind of piece of land that's like this maybe, and I have one side is 386 feet, the other side is 412 feet, and the angle that's between them is 71 degrees. So they've given me all the information I need to use the new theorem that we have. So the area equals 1/2 times one of the sides times the other side times sine of the angle. Okay, so when I multiply that out, let's see, I need my calculator. I'll have 412 times I get 75,183.86 square feet. If I plug that in my calculator correctly. No. Okay, I got something different the second time. Let me try that again. So I'm multiplying sine of 71 times, I'm going to multiply it the other way this time to see what I get, times 386 times 412, and then dividing by 2. Oh, I got the same thing that time. The second time I did it, I must have plugged something in wrong. So be careful as you're putting things into your calculator, because it's really easy sometimes to enter it wrong or not put parentheses where you need to, or something that will throw your answer off a little bit. All right, pause and try quick check 3, which is very similar to this example. You have two sides of a triangular building plot are 120 feet and 85 feet long. They include an angle of 85 degrees, and you're trying to find the area of the building plot to the nearest square foot. So the time before I rounded to the nearest hundredth, but here they want you to round to the nearest square foot. So pause and try that. Okay, so I was just drawing in the picture, and I'm going to use my 1/2 b times c sine 71, and I would get 1/2 times 120 times 85 times sine of 85 degrees. That's going to end up giving me, when I put it in my calculator, about 5,081 square feet. So make sure that if they tell you how to round it, make sure you round your answer to that unit as they've asked you to. Otherwise, you can round it to the nearest tenth or the nearest whole number, however you want to do it. Okay, try your homework problems and let me know if you have questions.